Hi folks, this is a video to accompany your lesson with solving and graphing quadratic inequalities. This goes along with section 5.7 in your textbook. So we're going to solve the inequality x squared minus 5x is less than 6. So what I'm going to do here is first of all ignore the fact that it's an inequality, and I'm going to change this to x squared minus 5x equals 6. And we'll come back to the inequality later on, but for right now I'm going to treat it like it's just an equation, and I'm going to solve this just like normal. So when I notice that this is a quadratic that has multiple terms, an x squared and an x, I'm going to get everything on one side. And I'm going to solve this like a normal quadratic. This one is factorable to x minus 6, x plus 1 equals 0. So I'm going to factor like that, and then I'm going to split these up. And I'm going to get what we call critical numbers of 6 and negative 1 from these two pieces. So what I'm going to do with these two numbers is I'm going to put them on a number line. I'm going to make a very generic number line that just has those critical values. And what I tend to do is I put little vertical barriers, if you will, that are going to be my boundaries between my intervals. So everything that's in this region over here, less than negative 1, is going to act a certain way, either all positive or all negative. Likewise, stuff in this region here, between negative 1 and positive 6, is going to act all the same way, either all positive or all negative. And same thing with stuff out here, greater than 6. Going to act all the same way, either all positive or all negative. So what I'm going to do at this point is I'm going to bring down my original inequality, this one right here, and I'm just going to write it up here so I can see it. And now what I'm going to do is I'm going to pick a number that's in this region out here and use it to test the inequality, see if that region holds true or false. So I'm going to pick a number that's less than negative 1, like negative 2, and I'm going to put it into this equation up here. So I'm going to do negative 2 squared minus 5 times negative 2, and the question is it less than 6? So a quick calculation here, I get 5 plus 10, is that less than 6? Well, that's going to be 14 is less than 6. No, that's not true. This region does not work. So now we're going to move on to the next region. I'm going to erase all this stuff. You can just use a different part of your paper here, but I'm going to just use my space wisely here. And now we're going to pick a number that's in this region, between negative 1 and 6, like 0. So 0 squared is 0, minus 5 times 0 is 0. Is 0 minus 0 less than 6? Yes, it is. So this region is true. That region works. Every number in that region is going to work. Again, I tested 0, but numbers like 1 and 3 halves and negative 0.5, those will all work because I know that 0 works. And now lastly, I'm going to pick a number that's greater than 6, like 7, and substitute that into my inequality and see if that works. Well, this is going to be 49 minus 35. I don't really need to carry that out too much, although I guess it's probably worthwhile just to check it. 49 minus 35 is going to be 14. Is that less than 6? No, it's not. So that region does not work. So what I'm left with is this region between negative 1 and positive 6. That's going to be solution to my inequality. What I'm going to check here is the actual inequality itself. If you remember, this was in a less than, not a less than or equal to. So because it's just a less than, our values are going to be between negative 1 and positive 6, but not including those endpoints. So I can write it like this. I can say negative 1, try this again, negative 1 is less than x is less than 6. Or x is between negative 1 and positive 6. You can also use interval notation. I can use parentheses, negative 1 up to negative 6, excuse me, up to positive 6. And notice I'm using the parentheses and not the straight brackets because I do not want to include those endpoints. Keep in mind that this is an interval, not the point -1 to 6. But anyways, both of these are solutions to our inequality, and all those values there should work in the original statement. Okay, so moving on to graphing an inequality. I'm going to take the same basic function. Notice how I moved the 6 over to the other side. And I'm going to graph y is less than x squared minus 5x minus 6. So the procedure is just like graphing a quadratic equation. I'm going to treat this like an equal sign. And I'm going to go ahead and find all the important information that we found before, like the x-intercepts, the vertex, maybe a couple more points, and I'm going to graph the function. Once I get to the point where I'm actually graphing the function, then we're going to add in the fact that this is actually an inequality. We did some work on the last page, and we found the x-intercepts to be, I think we said -1 and +6. So I know those are on my graph. And I know that my vertex is going to be halfway between them. Well, I'm going to actually eyeball most of this because the actual points aren't really overly necessary for us. So halfway in between is going to be, let's see, right about, I think this is going to be at 2.5. Let me just check this. 1, 2, 1, 2, 3.5. 1, 2, 3.5. Okay, so that looks like that works. So that's my x-coordinate for my vertex. I also need to now go ahead and find my y-coordinate, which I'm going to do while this is paused. Okay, so I did a little work on the side here, and I found out that the y value for our vertex where the x-coordinate is at 2.5. This ends up being -12.25. Well, that's a little bit off my screen, but here's still the point. So I'm going to put it way down here. And that gives me my general picture. My vertex is down here, and I have my x-intercepts. But again, this is kind of old stuff as far as getting the actual graph. So what I'm going to do now is I'm going to use the fact that this is a less than symbol. It's not greater, less than, or equal to, it's just less than. So that means it's going to be a dashed line. So I'm going to start from my vertex and draw that side going up. So I've got my dashed line going there, and that really breaks us down now into two regions. I have all this region in that's above the parabola, and then I have all this region which is below the parabola. And I haven't really decided which one it's going to be yet, or I haven't investigated which one it's going to be yet. I'm going to look at that right now. The shortcut for this is a nice standard form, so y less than the function. That really tells me that the shading is going to be all down below the parabola, and that would really be the end of the problem. What I'm going to do is I'm going to just make sure that this works and try a test point. So as I cleared all this out, I'm going to choose 0, 0 as the test point, and there's my point 0, 0. So what I should get here when I test this out is a false statement, because I'm saying that it's shading below the parabola, and this point right here obviously is above it and inside it, if you will. So if I put in the point 0, 0, do I get a true statement? Well, I get 0 is less than -6. Well, that's not true. So I'm not going to shade inside. I'm going to shade this outside region here as required by my testing that I did. And that's how we graph quadratic inequalities.